Today I'll be discussing Six Sigma's role in improving organizational outcomes. I'll do so by first discussing a bit of background on quality methods that have led up to the development of Six Sigma, specifics of the Six Sigma itself, and finally how Six Sigma has become widely used in many types of organization in today's business marketplace. Six Sigma gives organizations a new way to build quality, to use that quality to lead to improved organizational outcomes. Managers are increasingly required to use Six Sigma as a quality foundation. Therefore, understanding at least the basics of Six Sigma will help you to perform better in your job. Organizations can be demolished without a plan for quality. A plan that can be developed based on Six Sigma precepts. Six Sigma provides a quality framework for raising your organization's performance. Use Six Sigma to build quality into all organizational aspects. The Six Sigma process builds upon previous quality management techniques, incorporating many of the better ideas as well as adding new methods to the quality process. Prior work includes the Japanese approach to quality. This approach originated with Demming, a U.S. quality expert, and was then imposed on Japan after World War II. It was important to the U.S. that Japan be able to quickly bring back its factories to full production and therefore becoming economically independent. The method that the U.S. decided on to help Japan retrieve its economic abilities was to help them develop a quality management system. And this quality management system was spearheaded by several U.S. quality experts, including Demming. Demming believed that poor quality is caused by variation, and actually is variation itself is poor quality. Therefore, and also Demming believed that all improvements have to be implemented on a system level. It will not work to simply try and reduce variations where you see the variations occur. Rather, these variations come about because of some larger system defect, and to reduce the variation you have to change the system. Therefore, if you see that your products have too much variation in their size, you have to look to see what in the larger system is causing that variation. It's also important to remember that there are four categories of quality cost. There are prevention costs, appraisal costs, internal costs of defects, and external costs of defects. Each of these four types of quality costs have an increasing level of cost to an organization. Prevention costs are costs that are required to keep defects from occurring in the first place. While prevention costs may have a lot of upfront costs and may be more visible than some of the later types of costs, it is actually the least costly route to catch defects in the prevention phase. By redesigning your manufacturing or service system to prevent defects from occurring in the first place, you will have defect-free products that will give you the best return on your investment. The second level of quality cost is appraisal. Appraisal is when you check your output to see that it's met your quality standards. Appraisal costs are more expensive than prevention costs because you only find out that defects have occurred after they have been made. At this point, you can still rework or discard your output, but you've still incurred a cost in finding those defects and bringing those products, that output, up to quality standards. This leads to the internal cost of defects. Internal costs of defects include the costs that are required to bring your products up to standard. Internal costs can include rework costs, can include discard costs of getting rid of your product, can include cost of recycling your product, but still internal costs of defects are less expensive than external costs of defects. External costs of defects occur when your product leaves your transformation system and are bought by your customers. External costs of defects include warranty costs, but it also includes lost goodwill and trust on the part of your customer. At its highest level, external costs of defects can lead to loss of your customer base and potentially lawsuits. There's also been the U.S. approach to quality. The U.S. adopted quality approaches largely to meet Japanese competition. Especially in the 60s and 70s, the U.S. buying population turned more towards Japanese goods because of the real and perceived higher level of quality from Japanese products. Therefore, to regain its competitive edge, many U.S. manufacturing firms decided to also adopt quality improvement processes to meet foreign competition. Juran proposed a quality trilogy: planning, control, and improvement. These three steps would then lead to improved quality processes. Also, a standard approach to quality has evolved in the U.S. As the diagram shows, each step is part of a cycle where each step leads into the next one. You can start at any point in the cycle, but one way is first to determine customer desires. What is it that your customer wants from your product or your service? What is it that will delight that customer? You have to find out what the customer wants in order to be able to meet these customer demands. Once you've determined customer desires, you need to exceed customer desires. Quality, as is seen today, is not simply a removal, a lack of defects. Rather, it is exceeding customer desires, giving your customer something that he or she did not know they wanted or needed until they received your product. The next phase in the cycle is to develop a right the first time process. Develop a process where you're putting out products without defects that delight the customer every time, the first time. Finally, monitor the system for improvement opportunities. Once you have developed a right the first time process, now you need to start looking for ways that you can make the overall system better, making it more efficient, making it where it will make even better products, making it where it will be faster. Also, in all steps in this cycle, you want to include customers and suppliers. Customers will give you feedback to make sure that each step in each part of the cycle really does delight them. Suppliers are necessary to make sure that you can receive the raw inputs you need in order to delight the customer. Six Sigma uses the DMAIC improvement process. DMAIC stands for define, measure, analyze, improve, and control. Six Sigma provides managers with a well-defined and effective quality improvement process. managers must first define their situation. A major task for managers is determining how quality will be defined and measured. This task can often be met through benchmarking, comparing your processes with processes of other organizations in your same industry, in industries that do a given process very well, or with your own prior performance. Quality function deployment provides a way to track the linkages between customer needs and firm capabilities. The measure phase examines how well you're meeting your quality needs. One measurement is defects per million opportunities. How many defects per million of output that you have. You can also employ process sigma. You also need to determine how accurate your measurement system is through measurement system analysis. In other words, it's not enough just to measure your output, but you also need to make sure that your measurement process is reliable. The next phase is to analyze. Brainstorming can help you find relevant issues in your system. In what ways can your process be improved? Also, cause and effect diagrams can help you map out your process and are useful because they're a visual method of quality control process. Visual methods tend to be more useful to people involved in a quality improvement process because they give a very involved method of showing where problems can arise and how they can be corrected. Process capability analysis is also a useful tool to employ. The improve phase begins implementation of your quality program. It is often useful to design experiments to test alternative improvement methods. In other words, if you're running multiple shifts of a coffee shop, you may use one shift to try out a new method of dealing with customers or providing your coffee beverages. The Taguchi method focuses on output and designs in potential human error. Taguchi differed from previous quality improvement methods in that Taguchi made the assumption that humans would always make mistakes. Humans would always be a source of potential quality defects. Therefore, rather than trying to design a system that assumes that people will be perfect in their performance every time, you have to design a system that will allow for human variation and make sure that human variation did not lead to output defects or problems. The final step in the DMAIC is the control phase. Control can be accomplished through statistical quality control. Control charts provide a visual means to track quality, and as mentioned before, people tend to respond better and understand more easily visual tools for understanding a process. Therefore, whenever possible, include visual feedback in addition to any numerical feedback on a process. Six Sigma is a widely accepted business process across many industries. Began in manufacturing, and while still most applicable in manufacturing, has been adopted by the service sector, and Six Sigma is proving to be more amenable to the service sector than other prior types of quality management processes. And its success in both manufacturing and service has led to its adoption in the governmental area. How will you help your organization meet the quality challenge? All organizations must continuously improve to meet today's competitive pressures. quality management is a way to meet this challenge. Six Sigma is a flexible and powerful method of quality improvement. Using the Six Sigma process will meet your quality needs.